I get a question sometimes from students trying to learn how to solve statics problems. And the good news is that there is a process for solving these problems, and it works kind of like a recipe. So what I'd like to do is kind of go through the recipe with you, show you what the steps are, and then we'll go through a real simple problem and I'll show you how it works, okay? So here's the deal. The first thing you've got to do is you've got to keep track of what's given in the problem and what it is you're trying to find. So the first thing is identify givens and find, okay? What's given to you in the problem? What information do you have? And find, what information don't you know? What is the problem asking for? And what number do you have to generate so you know you're finished? Okay, second thing is to draw a picture. Now this isn't necessarily a free body diagram. In fact, it isn't a free body diagram. Draw a picture of the problem. Show everything you know from here in a picture. If you don't do this, you're opening yourself up to some problems. You're going to create problems you don't need. So the third thing is draw a free body diagram Okay, and that's just a simplified diagram that shows all the forces that in moments that you could be either trying to find or have identified. Fourth thing is to write out, whoops, maybe I can spell that right. And I'm going to call these equations of equilibrium. Okay? Equations of equilibrium mean that whatever the part is you're trying to analyze, it's not moving, right? That's the whole idea of statics. If it's not going to move, that means all the forces in x direction have to add up to 0, all the forces in the y direction have to add up to 0, and all the moments have to add up to 0, okay? Now, when I say that, I'm assuming we've got a 2D problem. If it's a 3D problem, there's just more equations. The process is exactly the same. So the last thing is now solve these equations to find out what it is you got to know, all right? And what it is you're trying to find here. Okay, this is where you actually come up with a number. So, I don't have a whole lot of room here. Tell you what, there's that. If you want to do a screenshot, there you go. I'm going to erase these and I'm going to draw a real simple problem, and we're going to solve it using exactly that recipe. Let's say you've got a rigid bar here, and it's pivoted in the middle. That's a pivot, and it's connected on that end. There's just a contact there, okay? And we've got 1,000 newtons down, okay? That's the drawing, okay? Now, I don't have quite enough information yet. What's given? Well, that's given. What is it I'm trying to find? All right. Find, let's find the reaction forces. And I'll call this point A and that point B, just because I got to call them something. At A and B. So we've got some more stuff. The only thing we don't know now is what's our coordinate system, and that's, we can kind of make that up as we wish. Okay, typically I'll use this one. All right, that's the positive sign convention. So x is positive to my right, up is positive y, and that way it's the counterclockwise is positive moments. We know all this stuff. So when we write this out, remember we can use the GFSA format, given, find, and I'll write down answer. Okay, and this is where, I'm sorry, let's say answer, write down solution, GFSA. There, that looks better. All right, now, what's the next step in the process here that I just wrote out for you? Well, we know what we've got given to us. We know what it is we're trying to find. I've got the diagram. We kind of took care of this all up at once. Next thing to do is write out a free body diagram, okay? So that's going to be a lot simpler than this up here. I've got 1,000 newtons there. I've got a force at B and a force at A. Now, this is simple enough. I think I guessed the right directions for those forces. What if I didn't? What if I guessed the wrong directions? Well, all that's going to happen is a negative sign will show up in the answer, and that's fine. That just tells me I've got the arrow pointed the wrong way. So the math will take care of you. Do what the math says, you're going to be fine. So there's my free body diagram. Next thing to do is write out equations of equilibrium. way. I wish I had a shorter name for it, but there it is, right? Well, there's only two things I don't know here. I don't know FA and I don't know FB. So I've got to write down two equations. If I can write down two equations and solve them, I can find two unknowns as long as they're not the same equation. Well, I can do this a couple of ways. One way is to say the sum of the forces in the y direction equals 0. Right? That has to happen. Some of the forces, if they're not 0 in the vertical direction, that means there's motion or there's acceleration. Well, I know there isn't, so I can set those forces equal to 0. All right, and that means that minus Fa plus Fb minus 1,000 newtons equals 0. Okay, so make sure the minus sign shows that I've got a downward force here, plus sign upward force at B. I guess I'll get out of your way here. And then minus 1,000 newtons down there. Those are reflected over here, right? If I want to make this a little bit simpler, I can, newtons equals, let's see, FB minus FA, right? Same equation written down in maybe a slightly simpler form. Right, so that's number one. That's the first of my two equations of equilibrium. Got to have another one. Well, there's no forces in the horizontal direction, so that doesn't make sense, but I can take a moment about some point. How about if I take a moment about B and set that equal to 0, okay? Oops. That equals 0, okay? So if I'm taking moments about that point right there, FA is going to make the beam want to rotate counterclockwise, right? So that's going to be positive. So, and I don't have dimensions here, darn it. When I wrote it down in my notes I did. That's 1 meter and that's 2 meters. My apologies for forgetting that. Alrighty, so that's going to be a positive moment, so I'm going to get 1 meter times FA. Okay, and this is going to be a negative moment over here. There's no moment at FB because the moment arm is 0. Alright, so that's minus 2 meters times 1,000 newtons, and all that equals 0. Alright, let's start here. There's one equation, one unknown. Let's solve for FA and then find FB. What I've really got here from a mathematical point of view, two equations and two unknowns. I have a system of two equations. Well, I'm going to solve this one, find FA, plug FA into that, and find FB. Alright, so let me write this down in a slightly different form. Okay, so I pushed that over to the other side of the equal sign and left that there. So 1 meter times FA equals 2,000 Newton meters. Notice I'm being very careful to track my units. Don't give up the opportunity to track your units because that'll help you. If you get the units right, the numbers will mostly come along for the ride. Okay, so it's a good way to check your answer. So I can cancel out meter there, and FA equals 2,000 newtons. All right. So that's an intermediate answer right there. So I'll draw a line under that. Well, if FA is 2,000 newtons, FB minus FA equals 1,000. FB must equal 3,000 newtons. And there you go. So there's the solution. Now, just to finish it up here in GFSA format, I need to write out answer. And I'll write FA equals, what did I say, 2,000 newtons. And FB equals 3,000 newtons. And I guess just to show I'm done, I'll draw a box around that. So there we go. There's the process. There's a couple of simple steps. Show those, laid those out for you, and then walk through them to form a solution to this problem. We start out with our drawing, find out what's given, what it is we got to find, did a free body diagram, wrote down our equations of equilibrium, solved them, and got the answer. And this is pretty typical of all statics problems. All of them work this way, and in every statics problem you're going to do some variation on this type of solution or this recipe for your solution. I hope this helps, and I'll see you next time.